We are live now. Okay. So from the last time, 2 hours mark, I left off with unsuccessful implementation of Twitter CLI there, because a lot of information to digest on that. But after a while, after that, I go through the documentation and found out that, yeah, the Twitter documentation is horrible, very horrible. It says something else, but actually you need to do something else to make it work. And I found out that in order to make it work, you have to enable all of the permission. Like there are 3 types of it: read, and the second one read write, the third one read write, and direct message. Even though you don't need direct message to read the message sending from other people, right? But you better enable this, because making a request to the API on the Twitter side to update the tweet, you need this. I tried several times and double check, triple check of the exit token parameter and all things of that. With only read write enable, it doesn't work. You have to enable all of it. Okay, so now it's a time to start implementing something now. Okay. Let's see. So what we need to do next is that I change to this one. Yeah. So the step that we need to implement next is to collect all of the required parameters in terms of like coding. Yeah. Collect all the required parameters, sort it automatically, and doing %encode on there, and at the end send the API request. So the library plan is that we're gonna implement all those ourselves and use code API to execute making internet requests first. There's just a few things that we need to require on other people, like algorithm to hashmag SHA-1 to, yeah, as part of the process of the collecting parameter here. As you can see, signature method. Signature method. Part of the process is that whenever we get base string, and you can see here, create a signature, we have to use this, and also a key as we got before. The key here, yeah, this is paid authentication, create a signature. We got 2 things in order to create the result of SHA-1 hashmag. That is, we need signature based string first, and then signing key. We use these 2 information in order to feed into SHA-1 algorithm to generate a string for us. Actually, we can see. Actually, we can like use OpenSSL to test on this kind of thing as well. So it's going along this kind of thing, like this is your content, and open SSL DST SHA-1 hashmag, and this is the key. So you feed this kind of information, and it's gonna generate the result for us. And in this case, this is the important step as well. Whatever they generate for us is the binary string. We don't immediately use that result in order to enter into base 64 just yet. We need to read per byte and use that instead. Yeah. Okay. Anyway, I'm gonna go follow along with the step here. Okay. Let's go back to the coding scene. Okay. This one is not. So let's create something in Lips. Yeah, I grabbed HMax-SHA-1 source code from the internet. Let's see how it looks like. So there's a sample. There's a how to call the function in this source file already. Okay, so okay, what should we do? What should we start? What should we start on? Start. Okay. Start with the collecting prompt. Okay, so because this is target on individually personal use, so we're gonna fix the exit token and also those secret value into the environment variable, and we lead those value via the apps using the get environment function. Okay. Yeah, I switch back and forth on the window right now. Okay. Yep, use this function to get the environment variable. So okay, so now I'm gonna set environment variable first. You don't see it because this is should be privacy. Yeah, I'm gonna set it. We need consumer key. And OR token. Yeah, we need two things: consumer key and OR token. TT. I call this application TT, so I'm gonna start TT consumer key. I'm gonna grab this from another window of mine. Yeah, but you won't see this right now. Yeah. Twitter apps. Twitter apps. Oop. Okay. Export TT exit token. Yeah, so it's basically okay for testing, debugging app or personal use of the app you develop with the reader. Just fix the exit token as consumer key there. But for the mass user that you develop the app and let other people to use it, you better use other authentication approach that already documented by the Twitter document there website. Something like a pin base or maybe OAuth normally, that making a request and you authenticate that okay, I authorize this app to exit my personal info or something like that. Yeah, but now we just cut short the process because we don't plan to just mass publish this thing, just personal use. So whenever the app publish to the user this way, yeah, user have to create the app manually and grab the key and token and then specify via this. So we're gonna have the README file going to explain the step on this. Excuse me. All right. Yep. Okay. TT. So I'm gonna source this first. Source the environment that we already add. Source. Right. And what else should we do? Create some files here. Oops, external. Oops. External. X2. I'm gonna change things. I think we should create a source in source folder. Source and external into the source as well. Yeah. Should be better. And the hex to be in here is just a testing file that I did. Oh. Hex to bin. Yeah, this is part of the process that as I told you, add this process. This is part of the creating signature here. Yeah. At this point, it will when we supply the signature based string and also signing key to the SHA-1 algorithm, we're gonna generate the string of this as a string. But in fact, it doesn't mean we need to read as a string. We need to read at per byte basis. So we just grab a pair of it one by one and then trade it at the decimal value and use that instead in order to enter into the base 64. And that's the source file that did it. Yeah, so I have the test source file that already work. Yeah, later we're gonna use this. Okay. First configuration hex to okay. TT should be more flat, much better. Okay, no. Query that's really separate for Twitter related source file. Okay, touch. This one going to be API. Yeah, I'm gonna go for the snake case in this one. I have changed from Pascal case to blending between snake case and also Pascal case, and now to pure and only snake case, and everything in lowercase, no more uppercase. Is reduce the time that you need to place on the chip. Right? Okay, API.h. API.h. Define API.h. Okay. So this is going to be the place to put the function related to this in here. Yeah. So we should do something about our make files here. File output tt out. Yeah. This will resonate with the git ignore. This is C flag. C flag here is going to be std C99 and let's produce debug info as well, and also L flag means that we don't have to lean against anything just yet, so it's empty now. Target is going to be blending between main source file and no, I should add also the directory of this source there. Source there is where source here tt Byrne tt. Okay, target is going to be at main and also tt. This is our Twitter related functions summing up together into the one object file. tt.o. So we can list this here. Okay, go for a simple case first, but actually I would like to go with more flexible way, like you define the dependency of Twitter library here and list all the files related to that in one variable, and then maybe you use that variable and also supply to the targets at this point, also here as well. But for now, I think we just list it one by one by our hand. No need to go that fancy just yet. Okay, for TT file is going to be what else? TT just API. Here I need to use source as well, so TT the can I change this to lowercase? I don't like uppercase. Yeah, let's see. TT the C flat L flat. You see output and target as well. Targets. Okay, change this lowercase. CC output TT the okay. TT the and the source file is api.c TT the again hash. Yeah, from my experience working with the Makefile here, we didn't define the header file as well. When you make change to header files, and Makefile won't going to recognize that, so you have to define it. CC yeah, this is for the lip size and out. Should be here, I think. Yeah. Okay, and one notice is that for the comparison of this kind of thing in the Makefile, we can just specify pair of implementation file and also header file in one place, one by one. We cannot just define all of this, like maybe you have some other file like a TT or C, no, just only one this time. Okay, so TT and then main.o tt.o I think this is correct. GCC I'm quite not sure this is correct or not. Oh, okay, it's not at this place. It should be the output one. Yeah, output one, in which case it is a tt.out and require on main.o and tt.o, and then we can link all the object file together in this place now. Can I define it all like this? No. Where is that? Yeah. And cc c flag. Oh, actually c flag. C flag should be existing for all the translation unit. gcc, yep, C here, compile, gcc compile, compile here, and translation unit, compile. This one, C flags here. I think this is right now. Compile with C flag here. And then this is a linking step now. So gcc linking all of them. So we're gonna specify the linking flag here. L flag, and output into our output file that we specify here. Let's test it. Let's test it. Let's go back. Yeah, so this is as source. As source, I have to add to as well. Base there, I'm gonna change this to base there. Base there. Base there. Yeah. Yeah, TT does. No. TT do. Output in base there. So the result object file from each translation and comparison unit is going to be existing at that directory. folder. Let's see what's gonna happen. I don't think this is going to work, but yeah. No such file directory. Yep. It's compile main and also API correctly into respective folder, and we link it together with tt.out, but at the linking step it cannot find main.o and tt.o, so we're gonna solve that. Yeah, we probably should what we can do easily than this is maybe just compile all the things and resolve all the object file in just one folder, in the build folder or something like that. So I think I saw in the CMake or things like that is require you to create a directory build with empty first. If you don't create it, it doesn't know, maybe because underlying system there require to see this in order to produce the object file into that. Yeah, but I just wanna go with produce object file in this directory instead. But it's a little bit cumbersome here to just add the part in front of the dependent file here. Anyway, you're gonna do that. Baster. Okay, we being so pragmatic here. So much of the explicit define everything here. That's the point for the level language anyway. Baster. Oh yeah. Baster. Okay, so this we just specify $@ in order to refer to the part that we already defined in the dependency name here, target name. tt is going to be tt.o. Okay. In this stream I try to make it like maybe 2 hours mark or something like that, not too long, not going to be 6 or 8 hours, something like that. So maybe there's going to be a follow-up of the stream about this implementation of the CLI later. Yeah, but definitely this stream should be better than the previous stream. I mean, the previous of the implementation of this thing, because the first time I will spend a lot. If you watching the stream, if you was watching the stream at that time, you're gonna see me just scroll through of the browsers, try to find the relevant information. Yeah, nothing actually happened in terms of implementation of coding. Okay, so we got main.o, tt.o, and output. Yeah, we're gonna output at the same directory at makefile. Okay, and we can go another one as well. Clean. So when we clean this thing, remove. Remove all of the object file. Can we remove recursively like this? Yeah, let's see first. Remove .out file executable, and we're gonna remove object file if there's happen to be. Let's see first. So making, okay, so all things out. Let's make target new by Araw. Oh, okay. And then, yeah, actually we at this we can specify just, yeah, the target here, and it's going to be, let us search a little bit. Let's search a little bit. So we're gonna try to how to get Eliott in Makefile. Okay. See my source this before as well. Makefile. No, this shouldn't be. Not in Bash. Okay. I search to what I definitely blend with fast script. I remember that I think I know about this thing before. Use without to remove element from array. Yeah. I did the research before, and I noted it down in one of my projects. I also push into the Git. So yeah, I just grab and find a little bit for. Could be there. Yeah. So filter out something else. Okay. So we can refer back to the target variable there and we can just do outtakes. Yeah, we can do it, define the linking target. So it's going to be filter out something else. In this case is output itself. Okay. This is, yeah, and let's refer back to target. So this should work, huh? This should work, I think. Maybe not a little bit. Remove out output at as part of target. Yeah, because we define all of the things that we already defined within the target here, but we don't want to just, if there's like a 15 or 10 or more than that defined here, we're not going to redefine all the things one by one again in this. So we just filter out, remove one that we don't need, and then just repeat all of the things that we already defined. Let's try this work or not. Okay. Hey, hello there. Thanks for coming by. So we're gonna try make. Okay, I think it's there. Let's see. Oh. I think maybe we go back. We go back all here. Oh, because this is TT. Gonna go. Weird. So it's going to be make5, and the next one is going to be main. Okay, we're gonna print something. So if we execute the tt.out here, it should print out. Okay, yeah. This is been okay. So our make5 is working as I expect now. Excuse me. Yeah, so filter out is working fine. We don't need to redefine of the dependency as part of the target again. So in this case, there just this is API file that we're gonna messing around with. API.h. Okay, okay. A part of the API is going to be source TT. Come on, TT. Okay, yeah. Okay, before we go into the implementation, I want to test something here. You see that there's already the object file that generate in that directory. Let's go back and make clean to see the effect of this. Make clean. It should remove the object file for us. Oh, it's not. So we need to do some recursive filing on that. Yeah, so we're gonna improve the clean target here a little bit by recursively file. So the file from the root directory, and if the name is about, oh, okay, we can test this here. Oh, source tt file. Yeah, it should be something that we can do. It should be the particular parameter that we can just specify into the file command right away, that we need to provide the file name there. No need to use the grep externally. I don't know. Oh, yeah. So name. But what about type? Type T to identify by type. Possible file type directory regular file. Yeah, type F. Okay, file type F, and name is should be over here. Illegal. What the? What is this? Illegal option T. Illegal option T. What happened? Type F file here, type F name. What part of this? Again, something wrong there. Type. Oh, it's the type. Okay, yeah, that we found it. So we're gonna use file here, this command, within the makefile. File type F name. Oh. And when we found it, we're gonna delete it. Yeah, it is in file command. That should be executable as well. Oh, here. True if the program name utility return a 0 value at the expression must be terminated by a semicolon. As many part. All right. Execute and then here. I think so. Let's try it. In this case, it's going to, we're gonna list all the information about that file here. We're gonna no terminate. No terminating. What is? Oh, right. Okay, we clean and then we execute, make again. So this is still okay. Our source file is still there intact. Okay, make again. And then make clean. should be no object file now. Alright, work now. Good. Okay, we can moving on. Our make file is okay now. And we go right there to the API first. API header. Excuse me, I need to check this a little bit. Okay. What is this? We need something else. YouTube. So in YouTube here, we're gonna add the function that help us to collect the parameter and encode the stub and things like that. Okay, so now we live 1 hour marks already. Okay. Let's make the most out of it for another hour. Okay, so the first utility that we need, let us check again. We need this. Okay, we need the things to generate the noise first. Alt noise here, parameter is unique token your application should generate for each unique request. Tutor will use this value to determine whether a request has been submitted multiple times. The value for this request was generated by base 64 encoding 32 bytes of random data. And stripping out of non-word character. But any approach which produce a relative random family should be okay here. We can go with simple case here. Just implement the random string generator for the length here. What the length here we have, and we can check it. Or maybe we go with the suggest approach with the encoding it with base 64 32 bytes. We produce this, and we have to work on top of it by stripping out all non-word character as well. Seems overkill for us right now. Yeah, maybe we just go with a very simple case here. Yeah, but anyway, let me check the base 64 algorithm first. Base 64 algorithm. If it's not too much, and maybe I gonna implement it as well. It would not be a problem. Okay, I switch to the resource. Right. Okay. There's already, oh, there's 22. Yes, it would be challenging to implement this. Yeah, or 3 miles, but then that. I would need the JavaScript version has better explanation for the algorithm that we need to go through. Maybe I can learn something from this. So it needs to be the multiple of 3. Yeah, for the input string, and we pad that with add the right 0 pad to make this string multiple of 3 characters. Yeah. And we pad that with equal sign, this thing. Add the right 0 pad to make this string multiple of 3 characters. Interesting. PC version. I don't know if I can do something for it. Maybe we just Aries. Okay, I think this is going to take a long time for this. I'm gonna shut this node down first. Shut this down. There's 64. So I'm not going to implement this now. Let's just go for randomize normally for the string. It would be better and easier. So okay, gonna excuse me, sorry. Still, I shut the microphone down just before time. just in time. Okay, add the prefix here and generate random string. Let's check. Oh, streaming has problem a little bit. Oh, streaming is slow now. Okay, back to normal now. I should drink water a little bit. Wait there. Okay, coming back. Yep. Generate noise. Yeah, I'm gonna fix it there as well. Generate the value for this request was generated by Jasper. Anyway, by any post we produce random. Generate random alpha numeric string. So alpha numeric string is the normal character combined with numerical. So yeah. The rent, yeah, we should check the rent here. We should check the rent. I check the rent on the command line like this. Yeah, but you need to remember to put parameter n here, because if you didn't put and you input into WC here, it's going to add one more byte, in which case that is the new line. You don't need it. So in this case 42. So let's see if you missing adding n parameter here, what's going to happen? It's generate 43. So it's not correct. So this is the byte that it generates. Is the byte. Yeah, generate byte. So 21. 21 character. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. No. Oh, okay. I miss it. It's 42 character. Generate random performance string in 42 character in range. With 42 character in range. Yeah, what is return is return string pointer in which you have less. No, I think it should not return string pointer here for better word. We're gonna accept the allocate buffer and we're gonna set that thing to the user space. Much better. Yeah. Destinations. Hello. Thank you for coming. I cannot read your name, but anyway. We are trying to make a simple version of the Twitter CLI at the moment. So parameter here is a DST. DST is destination string that will be filled with generate random string. Okay. The next step for us get TTU2 get ENV. So you see here we can check out the man page of the get environment function. Get env function standard lib as well. What is it requires us to input the name of the environment variable and then it will return back the character. Function obtain the current value of environment variable name. The applicant should not modify the string point to by the application should not modify the string point to by the okay. I need to check the return value from the get env here. If the name is not in the current variable, not is return. Since the man page doesn't say anything about whether or not we should deallocate the string ourselves, so that means that maybe it's handled by the function itself, by the system itself, so no need for us to care. Char. We're gonna return constant char here. Which is the name. Return value of input environment variable name. Value is string. You have no need to create it after you. So yeah. No, there's no such variable name. U2C U2 U2 generate noise. So constant char TT2 get env. Actually, this function is just a wrapper that we called we get env. Should be actually have no need to wrap it again. It's going to be cumbersome for that. No need. Delete it. Noise noise. 42 character in length. Okay, now it's time to think about the algorithm. We define the string and then we just random the index in order to fill the character. That's great. So if we check that BFT equal return, by the way. Actually, mostly I don't like to having a check inside in the function, something like a free or something is very clear to user that when they execute what they're gonna expect in that, because it will add the burden and also the reduce the performance in runtime by using the checking, something like this. If user uses this function, we expect to see the destination variable here not to be null. But in this case, it's okay, I think. Yeah. But for in terms of like if that function execute multiple times in 1 second in the game loop, something like that, it's much better to just ignore the checking. Yeah, we can do something like introduce a compilation flag in the makefile and then have it checked here, so it's not going to impact the runtime. Yeah, and when you compile, you can like set whether you need a debug build or release build or something like that, so you gain the difference of performance in both build. Yeah. Anyway, for this we go for the simple. And yeah, we should not redefine the alpha numeric string every single time the user use the function. So I gonna define it here. Okay, make it static control. Yeah, and we define is like this. This variable is going to live in the data space of the C program, so it is long lived until the app is killed, until the end of that. So it's gonna occupy the space on the app globally, but it will serve as well for this time, because we don't have to like spend time every single time using this function to redefine this variable again and again. It's very long as well. So imagine 26 character, lowercase and uppercase. So 26 is going to be 52 and plus 10, so 62 bytes that we need to redefine again and again if user use this and redefine inside the function, in which case we're not going to do that. Static control. Yeah, and static here in this case, it doesn't mean like in another programming language here. Static is mean that this variable is going to be seen in this file scope only. Other cannot see it, because everything in the C programming is just the public global state. You define variable a in this file, another file include the header of this, and in which case define the a variable. It's going to see it. And not just that, you define the variable in this without static, and when linking together the object file, the symbol inside is going to be duplicated. So yeah, that's why you need static. Static conchar, this going to be alpha numeric string. Okay, this thing waiting to for random. Hey, thank you people for coming. I cannot read your name, but yeah, Love Box Game, thank you for coming as well. Ni hao everyone. Oh, this time should not be ni hao anymore anyway. Yeah. So I live on multiple stream here, on Doju, on Twitch, and also YouTube. So people may be coming from the Chinese base and also Western, and I don't know. Anyway, alpha numeric string. Okay, we're gonna define A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. Okay, now it's uppercase A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. And now is the number 0, 1, 2, 3, 4, 5, 6, 6, 7, 8, 9. Yep. String used in randomized operation. Yeah, we should note as well that no. Although the document says something otherwise, that we all know that the random string that we need is going to be 42 character. But if user doesn't take that much care and just send to the pointer that not allocate enough of space, we are going to be a problem there. So I'm gonna also specify length for this buffer as well. So this is going to make sure that user know it. Length. Yeah, so we can cut this part out, make it more a little bit generic. Random alpha string up to input length. Yep, length of string, length of randomized string, to get. Yeah, so if we accept 10, we're going to generate 10 in length back. Length and should I introduce the assert or not? All length. Yeah, actually this is not that super clean just yet. We can introduce the assert header here and then like a pre-check inside the function that it should not be null and len, and we can print out the error string as well. But most likely this is just to make the life of the programmer a little bit better, but internal of the user, it's just they're not going to look into the function. Let me decide. Okay. This time just go for assert. Okay, let me search about assert. Okay, we're gonna introduce another file that includes something common for us. Assert macro test that the given option for. If expression is true, assert macro does nothing. The assert macro may be removed at compile time with the CC option. Yeah, so this is the visual point here that we can disable this kind of checking, so we have the better performance at runtime by defining no debug, n debug at inside the makefile. Yeah. Okay. Let me decide to do this. Let me make TTU2. We're gonna create it. Common.h. So you can look. Okay, so this is a common header file, so every single file will include this thing. Every single header file. This is going to include. Let us go back to that assert function a little bit. Maybe remove as with this. Okay, so for safety, we're gonna check as well. If not define n debug, we are not going to include this header because if we, I don't know, it be pragmatic here and be safe to not include this file unnecessary here. So in time that we don't need this, we check it and we're not going to include this file. So this is assert.h. Yeah. Not include assert header file in time that we don't need it. And we go back to U2 and then include this one. Include command location. Yeah, so no, I should not include this. Include inside. Include inside. Yep, let's change this thing to common debug. Let's change this thing to common debug. And change this file to common debug. Okay. Common debug. And inside the implementation file of U2, we're gonna include that file as well. Common debug and in this case we automatically include such thing already, and we can remove this two line and check it as such. Let me check the man page a little bit. Check the man page. As such, expression here. You can see we can also specify which file and also which line as well. Interesting. Okay, I may use that as well. So check that the DST need not to be null, should not be null. That's before oh, okay, it's just written for us automatically. How can we have an assert that has fail assertion? It should be much better if we can specify the custom message as well in assert. Let me check whether we can do that. Custom message to assert. Okay, let's see. As custom message, yeah, it seems like people also try to find a way to do this. A hack I have seen around is to use an operator since the pointer is true. If it's not null, you can do the following without altering the condition. Oh. Yeah, the pointer is a pointer that we define the string here is always non-null, so it's going to be true. So it's not going to change the logic of the statement. Yeah. And from the man page file is that the assert will always print out the error message here, and also along file and which line is that. Interesting hack. Destination string should not be null. Yep. And we assert another one again. Length should be more than 0. Yep. Resolve should be more than 0. We're gonna test this. Yeah, actually, we can test it now. Remove this. Let's see. Right. tt ut.h. Yeah, so we're going to call that function here. tt generate noise. Destination, it should not be null, yeah. And let's see what's gonna happen. Make, no. Source file. Make generate noise. Oh, okay. We need to modify the make file a little bit because here we include tt, but the root folder for us is beyond that, up by one level. Make file excuse me. What we gonna do? I forget what we're gonna do now. Let's go back. Oh, include header file. Include header file. Include header file. Yeah, we're gonna modify C flags here and include. Tell the system, tell the compiler know that we're gonna include as the source folder. Yeah. So let's make it again. Make clean. Make again. Reference from main. Undefined symbol. What happened? Maybe something wrong. TTU2 generate noise. U2, let's see. TTU2 generate noise. Yeah. Oh. Okay. I think it's because we make it super hard for inclusion to be there. So I think we're gonna modify makefile to make it more flexible to inclusion of the header file. So it's going to be source. It's going to be at, let's see here, source and TT, sort TT, also sort external. Up TT. Okay, let's try it again. Oh yeah. What is this? Oh, my mistake. My mistake. This is not. I'm not going to be used. I didn't add. This is going to be API. TT U2.0. This is API here. This can be U2. U2. Make it again. Alright, this time should be okay now. Use of undeclared and declared now. What is this? Yeah, stdio to have now here, I think. Yep. And now the assertion failed. DST not equal to null and our destination string should not be null. This is our message of the error message. yeah, the hack is great. The hack is working. That solution, they're gonna thumbs up a little bit. It's working fine. Short note this down. Technique. Okay. Moving on. We have that already. Just we can do just one more check here. Let's see. We can have something like a char buffer 42 and then buffer, and this time it should return out alert that the answer is, yeah, resource string length should be more than 0, in which case, yeah, so if we change to 10, it should be okay the same. Yeah, no, nothing is printed out. Yeah, okay, we're fine now. We are fine now. And then we can go here and generate noise here. Go to the loop. Go to the loop length according to length, and then random. Yes, random. We can have random here right away. Yeah. Ran. I'm not sure which header file to yet. Let me search a little bit. Let's search a little bit. What's this? Don't need this. Okay, yeah, we're gonna use the libcode later in the process, but for now, no. So I forget how to random in C now. Random in C. Which header file? stdlib. Yeah, I remember that we need to set the seed according to the current time to make it random differently every single time we execute it. Oh yeah, this is exact the things that we need to do. So we're gonna use this sran right away. So I'm gonna move this to this. Change to coding. Right browser. Okay. We're gonna have some initialize and in order to call this function, and then it will set the seed first for the use of the random function later. Initialization of util. Call this for the first time using it. Quantity util. Yeah. Yeah, and I always avoid to include the file in the header files because it's going to make put the burden to the source other source file that include this file, that file, because it's going to increase the time in comparison. Okay, include, what is that? Time, include stdlib. Yeah, gonna set the seed here. Set seed in random function. sran. Yeah, and the approach is very good because we get the current time. So if we go back to the main file, we can initialize it. Okay. Yeah, we can have bunch of the random function here, like random between this and that. Yeah, but we're not going to export that as API to the outer. We just use it here. So random. This is going to be internal. So random I. I put underscore at the end because if you put underscore in front prefixing it at the function name, that's the undefined behavior because the C compiler will they tell us that they're gonna add the underscore at first before the things variable function name as necessary to maintain or do things. It's going to be max yeah. Yeah, I love to define the function signature here first before I go to the implementation of that function, because I can use such function in the whichever order I like it. No need to worry about I should define it first or something else. Okay, random return random, then we're gonna max. So this is going to be inclusion, so we're gonna also +1. Yeah. Random integer form. Hey, thank you for coming, people. Thank you. Random integer from 0 to max. Yeah, this is inclusive. Yeah, but normally random function is just most of the implementation is like a exclusion and the max. Yeah, so this is we're gonna use this. We're gonna use this random I here. The length of a primary string is I should define is that yeah, for the performance purpose. No need to go to the size again every single time. alpha. This is pre-calculated. Yeah, I don't want to just call site up every single time. So we're gonna count. We're gonna count the length of the string here. 54. Oh yeah, 54. Oh. A B C D E F G H I J K L M N O P Q R S T U V W X Y and Z. A B C D E F G H I J K L M N O P Q R S T U V W X Y and Z. That's why it's very weird. Echo here. 62. Yeah, 62. P calculate to cat the length of alpha numeric string for better performance later. Right, so I should change the variable name a little bit. Make it short. Alpha. Right. Alpha string alpha. Okay, so we're gonna st length alphan string length. Oh. Inclusion. Let's change it because it's index based, so it's just no need to use that. It's exclusion. Okay, we're gonna involve using the pointer here a little bit. So the pointer should point at the starting of the string on the input. String from the input, and then yes, dst here 1. And then we just get form of our string. And when we're done, we're gonna no need to return anything because we just changed the value already. Let's see. Let's see. So we're gonna define character buffer, maybe 4. Just testing first. Yeah. Mostly I need to define like this. Yeah. Anyway, TTU2 generate noise buffer. Length is 4. Yeah. Because we should allocate 5 because 1 for non-terminate character. So, and we specify that we want 4, length of 4. Yeah, this is tricky a little bit in terms of like a define the character of the character in array of the character in C. You need to always define 1 more byte for the null character. Okay, so I just want to check whether our function is correct or not. %s buffer. Okay, let's make it. Wrong name. 19 back one. PL set I. Yeah, that's working. That's working. So what happened if we just specify size of not 4 but 2? Make it again. So we should have C intact at the 3rd position. Yeah, that's right. That's right. Let's make it like a D. So we should have C and D intact, but the first one is going to be changed. Yeah, that's correct. That's correct. Let's see. Okay. Okay, let's see what else we need to do. Yes. Yeah, and we add the 2 hours mark now. I plan to stream for 2 hours first, and then we do multiple of it afterwards. So what we already done today is that we're gonna sum it up right now. We try to create the utility function here in order to provide us with a generation of like random string signature and collect all the parameters for us, prepare to send the API later on. Right now we just add the basic step first to prepare all the parameters we need. So what we did right now is we already done with the noise here. Yeah, we can have the randomized string at the up to the length that we input into it. And okay, let's change it to this much better. Let me do this. Yeah. So right now, noise is there. We have, and what else? We're gonna do noise and also get time step here. And next thing is the signature method. So this signature method is a very major thing that we need to implement. It's involved that we need to do. This is the detail of it. We need to collect all the parameter later on. Yeah, like you see here. If we need to like send a tweet, include something like that, consumer noise, and then we need to sort it and combine together, prepare in the result of signature based string as you see in here. Along the way, we need to also do the parent encoding. The parent encoding algorithm is here, so we're gonna do this as well, implement ourselves. but we're not going to implement the SHA-1 algorithm. No, we're going to use it library else elsewhere. And when we get the signature based thing here, we need to get the signing key as well, in which case is very simple to do. Just combine the consumer secret and also OAuth token secret here. Yeah, so we are good to go at this point. And a little bit of step later is that we need to calculate the signature by using the signature based string and also signing key combine together and push it, and then let it calculate the signature for us, because we need it to supply add the signature here. You can see signature here as part of the parameter in the header of the HTTP request. Yeah. And this one is a little bit need to be carefully looked at, because the result from SHA-1's algorithm is not right the way that we need to put it in the base 64 just yet. We need to read it in the hex string and treat them as a pair as a byte stub in order to get some kind like this. If you immediately get the result from the SHA-1 algorithm and use it as the input for the base 64, you're gonna get longer string compared to what it shows on the document. Yeah, so good progress that we made right now, and that's it for today. Yeah, see you guys again later. Okay, bye bye.